Alright, good morning, 4th grade. Today we're going to be going over equivalent fractions. So this is our objective, and it says that we are going to explain why fraction a over b is equivalent to a fraction by using visual fraction models with attention to how the numbers and size of the parts differ, even though the two fractions themselves are the same size. And we're going to use this principle to recognize and generate equivalent fractions. Now that's really confusing, so our can statements kind of simplify that for us. So let's read them together. I can recognize equivalent fractions. I can make equivalent fractions. So before we get started on that, we need to do a little review. So, and go over some vocabulary. So what is the top number called?
The numerator.
Okay, very good. And Nadine, can you read what the numerator tells us?
Well, the numerator tells us how many parts of the whole are being counted.
Excellent. Okay. What is the bottom number called? Angela?
The denominator.
Awesome. And what does it tell us?
How many parts of the whole are...
That's close. How many equal parts are in the whole? So you were almost perfect. You just forgot the equal part. So that'll be our next one. So, how many equal parts are in the whole? Now what we're going to go over today are equivalent fractions, which are two or more fractions that look different but have the same value. So before we can make equivalent fractions, we have to know what they look like. Alright, so what we have here is called a fraction wall. And it's basically broken down from our whole, which is this orange piece right here, into a bunch of smaller fractions underneath it. So when we look at the yellow, how many pieces is it broken into? Angela?
2.
2, perfect. So what fractions will we be working with if we have 2 equal parts? Nadine?
1/2.
Half, perfect. How many parts do we have for the red? Angela?
5.
5, awesome. So what fraction is that? Nadine, can you tell us?
Fifths.
Fifths, awesome. And how about the white rods? Yes?
10.
10, awesome. So what fraction is that?
Tenths.
Tenths, perfect. Okay. Now, if we take this yellow rod and compare it to our white rods down here. Awesome. So if we compare it to our white rods, how many white rods is a yellow rod equal to? Maybe
5.
5, awesome. So if we have 5, what is our fraction for the white rods?
5 tenths.
5 tenths. And what did we say our yellow rods were?
1/2.
1/2. Do they look the same?
No.
No, not at all. But if we look, like our definition said, they don't look the same, but they have the same value. We can look at the size and see that their values are the same. So they are equivalent fractions. So, now that we've looked at those, we're going to use another type of chart to help us find equivalent fractions. Okay, so these are called fraction strips, which look a lot like the Cuisenaire rods that we just worked with, where we have our whole at the top, and then all of our fractions broken down into smaller pieces to the bottom. So, it's the same idea to find an equivalent fraction here, where you just basically need to find fractions that are the same size. So, how we do that is say we want to find what fraction is equivalent to 1/2. So we find where 1/2 ends, and we look at that line. Then we look down the rest of the page to see what other lines match up with that 1/2. So you can use a ruler or a pencil and line it up, and we can see that these lines for, how many fourths is that?
2/4.
Or 2/4 is the same size. So while they don't look the same on paper, they have the same value or the same size when we look at them on our fraction bar charts. So I want to see if you can find a couple of equivalent fractions.
So I have a 1/2.
Mm-hmm.
Do I need to do a half?
You can pick any fraction as long as its line equals another
Okay.
line so that they're equivalent.
Okay, so I'll do. What cell do I have?
Okay.
And then I have, so that's 1/2.
Mm-hmm.
And then I have 2/4.
Good.
And then I have 3/6.
Very good.
And then 4/8. And 5/10. And 6/12.
Perfect. That's awesome. You found a bunch of equivalent fractions, and that's great. And we know that they're all equivalent because when we look at their size or their value, they all have the same size, and we can see that when we line our marker up with them. So that is perfect. All right, so to wrap up our lesson, we're going to look at our I can statements again. And our first one is that we could recognize equivalent fractions. So that was the first thing that we went over with the Cuisinart rods on the board, where you could see that when we moved the yellow rod down, it matched up perfectly with the other rod, with the 5 white rods. So you can see and recognize the 2 similar sizes. Then we moved on to the fraction bar charts, where we said that we can make equivalent fractions. And we did an excellent job of that, and we found a whole bunch of equivalent fractions that equal 1/2, like 5/10 and 6/12. And so we have covered our I can statements, and that's all for our lesson today.